Here we have a SAT math question. What is the largest possible value of the constant c so that x positive c is a factor of 3x cube positive 15x square negative 378x? Okay, first let me take that p of x equals to 3x cube positive 15x square negative 378x. So that is, I assume that p of x represents a given polynomial over here. It is given that x positive c is a factor of this polynomial over here. So now let me equate this factor to 0 and solve for x. So for that I have to subtract c from both sides. This positive c, negative c will cancel. Then I'm getting c equals to negative c. Okay, since x positive c is a factor of this polynomial p of x, then when I plug in this negative c for this x over here, it must be equal to 0 by factor theorem. So now what I can do is I can plug in this negative c for x over here. So because we replace this x by negative c, so when I plug in this negative c for x in this polynomial, then I'm getting 3 times negative c whole to the third power positive 15 times negative c the whole square negative 378 times negative c equals to 0. The evaluation of this negative c whole cube is still negative c cube because we have odd exponent over here. This negative will remain same, then 3 times negative c cube positive 15, and here we have even exponent for this negative c, so this negative will become positive. So the evaluation of this one is just c square, negative times negative will become positive 378 c equals to 0. And when I multiply 3 and negative c cube, I'm getting negative 3 c cube positive 15 c square positive 378 c equals to 0. When I look at the terms of the expression over here, all of them have the greatest common divisor 3c. So we can factor 3c out, and since the leading term is negative sign, we can factor negative 3c out. So once the negative 3 is factored out, so what do we have inside the parenthesis over here? To know that, I have to divide each of these 3 terms by the one I factored, that is negative 3c. So now first let me divide the first term negative 3c cube by negative 3c. So this negative will cancel, 3 will cancel out. When I divide c cube by c, I'm getting c square. So I have c square in the first term. Now to get the stuff over here, I have to divide the second term positive 15 c square by negative 3c. So positive times negative will become negative, and 3 goes into 3 1 times, 3 goes into 15 5 times. When I divide c square by c, it's just c. So finally I'm getting negative 5c over here. Okay, now let me divide the third term positive 378c by negative 3c. So here we have positive sign, positive times negative will become negative, and 3 goes into 3 1 times, and 3 goes into 3 1 times, and in 7 2 times, and we'll have 18 over here, and 6 times, and c will cancel. I'm getting negative 126 because positive times negative is negative. So negative 126 equals to 0. Okay, now I have factored the expression over here. Okay, now the product of these two quantities, that is negative 3c and this quadratic expression equals to 0. So whenever the product of two quantities equals to 0, either the first quantity equals to 0 or the second quantity equals to 0. So now let me equate the first quantity is 0, and now I equate the second quantity, that is c square negative 5c negative 126 equals to 0. Okay, now to solve for c in this one, I have to divide both sides by negative 3. Let me do it. So negative 3 will cancel. I'm getting c equals to 0 divided by any non-zero number is still 0. Okay, now to solve this quadratic equation, I think it can be solved by factoring. So for that, I have to multiply the constant of negative 126 by the coefficient of c square, that is 1. So 1 times negative 126 is negative 126. Now I have to get two factors for this negative 126, so that the product of the two factors equals to negative 126, and the sum of the two factors equals to the coefficient of c, the middle term negative 5. I think positive 9 and negative 14 will work, because when I multiply positive 9 and negative 14, I'm getting negative 126, and when I add positive 9 and negative 14, I'm getting negative 5, which is a coefficient of c. Okay, now to get the two values for c in this quadratic equation, I have to divide both these factors by the coefficient of c square, that is 1. Even if I divide these two factors by 1, still I'm getting the same result, positive 9 and negative 14. So now to get the two values for c, I just have to change the sign of each of these two factors. So when I change the sign of the first factor, positive 9, it will become negative 9. And when I change the sign of the second factor, negative 14, it will become positive 14. So I'm getting three values for C. One is 0, and other one is -9, and the third one is 14. According to the question, we have to find the largest possible value of the constant C. So among these three values of C, the largest value is 14. So the largest possible value of the constant C is 14.